Starting. All right, 2.1 to 2.7. I'll just go through the sections. We'll do two problems each, and then if there's time left, we'll go back and do some other ones. All right, everybody do this problem. This is number 2 in 2.1. 2x minus 4 equals negative 9. I'll pause it each time, and then you guys finish it. All right. So we're going to add 4 to both sides. You get 2x equals negative 5. I'm going to divide off a 2. And you get x equals negative 5 halves. Good? Okay. So now let's go on to this problem. This is, let's use 32. Let's use 4 over 2u minus 3 plus 10 over 4u squared minus 9 equals 1 over 2u plus 3. Okay, so I need a common denominator to add fractions together. So this is the difference of squares here. So we're going to change that to 2u minus 3 and 2u plus 3. Because when you add fractions, you need common denominators, common factors. So the left side, if we do, of course, we have an equation. So in an equation only, if you multiply by the common denominator, all your fractions go away. But that's only in an equation. Okay, if there was no equal sign here, then you have to actually get your common denominators and then add everything together. So we're going to multiply everything by a common denominator, which if we did that, I'll just write it up here, 2u minus 3, 2u plus 3. So if we did this to every term, this is what it would look like. Here the 2u minus 3 would reduce out, and you'd be left with 4 times the 2u plus 3 in the first term. And if we keep doing that, obviously if we multiply the second term by that common denominator, that's what the common denominator is. So you'd just be left with 10 in the second fraction. So again, just to show you, and then we'll go faster after this. Those reduce with what your denominator is, leaving just the 10. And you do it with the other side of the equal sign, 2u minus 3, 2u plus 3. And the 2u plus 3's reduce out, leaving 1 times the 2u minus 3. Okay, now we distribute and then combine like terms. Okay, so distribute there. Obviously, 1 times that is just going to be that. So 8u plus 12 plus 10 equals 2u minus 3. So this is 8u plus 22. So now I'm going to subtract 2u to the left. And I get 6u plus 22. Don't drop the minus sign, please. And now we're going to subtract 22. And we get 6u equals negative 25. Divide off the 6. And u equals negative 25/6. Let's move on. 2.2. This is your application problem. So this is, let's do number 1. A student in an algebra course has test scores of 75, 82, 71, and 84. And what score on the next test will raise the student's average? So this is average in stats. Average equals 80. So what score do we need to add to this to make the average 80? Okay, so in general, what we have here is 75 plus 82. And if you don't show your work, you don't get any credit. So if you just write down this answer, you don't get any credit. So if you're doing it all on your calculator, make sure you write down what you did on your calculator. Okay, so we have 4 tests we've already taken. We want to know what we get on the next test. So that's going to be 5 tests that you have to take the average of for it to equal 80. That's how you do it. Okay? So 75, 82, that's 157. 228. Is it 312? Anybody add those together? Yeah? Okay. So now we multiply by 5 on both sides. And that's x plus 312 equals 400. And we subtract the 312. Just algebra at this point. X equals 88. So show everything, all your work. Now let's go to section 3. Let's do 3 problems from here. 4x squared plus 13x minus 35 equals 0. Solve for x by factoring, please. Okay. 4x and x, and 5 and 7, because that's 7 and that's 20. Subtract 7 from 20, you get 13. All right, so 7 has to be negative, 20 has to be positive. So set each one equal to 0. And you solve it. Add 7, divide by 4, 7/4, and negative 5. Anybody finish first? Get it done? Okay. All right, another problem. Let's make it harder. Yay, right? Complete the square. And quadratic formula. This problem. X squared minus 4x minus 2 equals 0. Complete the square and then solve it again by using the quadratic formula. Okay, so completing the square. What you need to do is A needs to be 1 and C needs to be moved to the other side. So that should be equal to 2. A is 1. If it's not, then you have to divide everything by it. Okay? Then what you do to complete the square is you take B, which is negative 4. It doesn't matter that it's negative. And we're going to take 4 over 2, and we're going to square it and add it to both sides. 4 over 2 is 2. 2 squared is 4. Leave it in fraction form. 4 over 2, you could leave it as 2, but if it's a normal fraction, just leave it as a fraction. Because what happens is, you use those values, x and a minus, and what goes in this position is just b over 2, not b over 2 squared. That's how you complete the square. And then we finish the problem by taking the square root of both sides, and we get x minus 2 equals plus or minus the square root of 6, which does not break down. I expect you to break it down. Leave it in radical form, but you must break it down. 6 doesn't break down any further. Okay, so now we add 2 to both sides, and we get 2 plus or minus the square root of 6. That's completing the square. Now let's do quadratic formula. A is 1, B is negative 4, and C is negative 2. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Make sure it's all over 2a. So x equals negative b, which would be positive 4, plus or minus b squared is 16 minus 4 times a times c, and 2 times a. So 4 plus or minus 16 minus negative 8 all over 2. Minus a negative is plus a positive. So x equals 4 plus or minus the square root of 24 all over 2. The square root of 24 breaks down into 4 and 6, which is 2 square root of 6. So again, x equals 4 plus or minus 2 square root of 6 all over 2. The 2 will reduce into both of the terms in the numerator. 4 divided by 2 is 2. 2 divided by 2 is 1. Square root of 6. And notice they are the same. Excellent. All right, moving on. All right. A plus BI. Write the expression in terms of A plus BI. So this is number 4. Negative 3 plus 8I minus 2 plus 3I. Go. Okay. Don't forget that it's a minus. We're not multiplying here. So we need to distribute that minus through. So we get a negative 3 plus 8I minus 2 minus 3I. So put your like terms together. Your real numbers, A, negative 3 and negative 2, gives you negative 5. And then your imaginary numbers, 8 and minus 3, would be plus 5I. And that's the answer. Who got it right? Let's do this. This is number 18B. I to the... Well, I'll change it. Let's do positive 55. It's negative 55 in the book, but we'll do positive 55. I to the 55th power. Go. How many times does I to the 4th go into 55? I to the 4th is 1, so that's a good thing. So 4 times 13. Power 2 or power is multiplication. So 4 times 13 is 52, so we need 3 more. So I to the 4th is 1, so 1 to the 13th power gives me 1. I cubed, or what's I cubed? Negative I. Okay. I squared is negative 1, isn't it? So I squared times I is I cubed, so I squared is negative 1, negative I. That's the final answer. So just in case, I squared is negative 1. I cubed is I squared times I, which is negative 1 times I. And I to the 4th. I squared times I squared. Negative 1 times negative 1, which is 1. Let's move on. This is number 24. Negative 3 minus 2I. All over 5 plus 2I. Begin. All right, what you should have started out is multiplying by the difference of squares formula. You can't have I in your denominator, and there's more than one term, so you got to multiply by the difference of squares, which gives you 5 squared minus I squared on the bottom. 2I squared, sorry. And then on the top, you have to distribute binomials. So let's do that. Negative 15, positive 6I, minus 10I, plus 4I squared, all over 25 minus 4I squared. So that's the first step. Second step, combine like terms and simplify. So remember, A plus BI is the form we're really looking for. So your real numbers are first. That's a real number. I squared is just negative 1, right? So this is negative 15 minus 4, or negative 19. 6I minus 10I is minus 4I. And again, that I squared just changes it to its opposite sign. So that's 25 plus 4. Or 29. Nothing simplifies. That would be enough. But to put it in terms of A plus BI, technically it's negative 19 29ths minus 4 29ths I. That's technically how you should write it. But this is okay. I mean, you got that far, that's pretty good. 2.5. Real quickly, everybody do this one. This is number 2. X minus 7 absolute value equals 3. Go. Okay, Split these up. X minus 7 equals 3, and x minus 7 equals negative 3. Add 7 to both sides, and you get 10 and 4. Who got it right? All right, easy one. Let's keep going. Let's do something like this. Number 20 is 3 minus x equals 3. 3 minus x is under the radical. Okay, so we add x to both sides. Square root of 3 minus x, because you got to get your radicals by themselves if you can. And then we square both sides. So you got a binomial that needs squared. The radical goes away on the left. And this is x plus 3 times x plus 3, which is x squared plus 6x plus 9. So add x and subtract 3. Oops, x. 0 equals x squared plus 7x plus 6. So you got lucky. This factors x plus 6, x plus 1. So your answers are negative 6 and negative 1. Let's do 35. Now let's do 36. 2x to the fourth minus 10x squared plus 8 equals 0. Go. We only have 6 minutes left, so let's I'm just going to go through these. Okay, so just do problems like what I'm showing you here. I can divide off of 2. And then as long as the middle exponent is half of the leading exponent, then treat it like you're just factoring normal. So x to the fourth becomes x squared. Those are always what your middle exponents are supposed to be. And then factors of 4 that give me 5 would be 1 and 4. And it needs to be negative 5, so negative 1 and negative 4 give me negative 5. And negative 1 times negative 4 gives me positive 4. And now you have the difference of squares in both of those. So this becomes x minus 1, x plus 1, and x minus 2, x plus 2 equals 0. So your answer should be, 1, negative 1, 2, and negative 2. Okay, next problem. This is 2.6. Everybody answer this one. This is number 24. 3 minus 5x less than 11. Okay. Subtract 3. You get negative 5x less than 8. Divide off the negative 5. And you get x is greater than 8 over negative 5. You got to change the directions of the inequality. Write it in interval notation quickly, please. Okay, you should have had negative 8/5 to positive infinity with parentheses. It's number 70. 2 over absolute value of 2x plus 3 greater than or equal to 5. Solve it. All right, so there's 3 minutes left. Let's do this. Got to get the absolute value out of the denominator, so you multiply by it. And you get 2 greater than or equal to 5 times 2x plus 3. And I like to get the absolute value sign by itself, so I divide off the 5. So 2/5 is greater than or equal to the 2x plus 3. And I also like it on the left, so I'm going to switch everything. 2x plus 3, instead of greater than or equal to, it's now less than or equal to the 2/5. I like everything on the left. Now I split it apart. So let's move everything up here. So 2x plus 3 is less than or equal to 2/5. And then 2x plus 3 is less than or equal to, greater than or equal to negative 2/5. So you got to change the direction of your inequality and the sign. Subtract 3. So 2/5 minus 3 over 1 multiplied by 5 to get a common denominator. So 2 minus 15 is negative 13 over 5. And divide off the 2. Fraction inside of a fraction. You get negative 13/5 times the reciprocal of the denominator, which is negative 13 over 10. Subtract 3. Negative 2/5 minus 3 over 1. Again, common denominator. Negative 2 minus 15 is negative 17. And then divide off the 2. And you get negative 17/5 times the reciprocal of the denominator, which is negative 17 over 10. So x is greater than or equal to negative 17/10. Less than negative 13/10 and greater than negative 17/10. 17/10 is less than the negative 13/10. So it's equal to, so they're brackets. That's your interval notation. That's the way it should have been. All right, so time's up. You already know how to do 2.7. Make sure you can do a chart. Okay, done. Pick up here for the 8th period class.
There's like a fraction, and I didn't really know what's going on there.
Okay, find one that you want. So
I think it was. There's one really weird. I don't think you know me. Grab it.
okay, so let's pick up on number 35 on 2.7. We didn't get to 2.7 in the first class, but it's your homework, so it is what it is. So if they're watching this, they can see 2.7 first, all right? So you said 35?
Yeah.
All right, so like 35 here, 1 over x minus 2 is greater than or equal to 3 over x plus 1, all right? So you got to get 0 on one side, so we need to subtract that term to the left. So 1 over x minus 2 minus 3 over x plus 1, greater than or equal to 0. So are we okay with that step? It has to be set to 0 so we know whether or not we're looking for positive or negative value. So greater than or equal to 0 is positive. So that's the first thing you have to understand. So if you can understand that, what's the next thing? Is that where we're stuck? Yeah, so from chapter 1, you have the expression on the left here where you got to put those together. So common denominators. So this is an x minus 2. We're missing the x plus 1. So you multiply the top and the bottom by x plus 1. And on this side, you multiply by x minus 2. Gabriel.
Won't they be common if you just do the right side, negative 2? Like,
So let's go ahead and distribute through. Do not forget the negative. And then we just simplify at this point, okay? So that's x plus 1 and a minus 3x plus 6 all over your factors. Greater than or equal to 0. So how are we with that? Good?
Yeah, I can do that.
Okay, so now we simplify from here. And x and minus 3x is minus 2x. And plus 1 and a plus 6 is plus 7. All over your factors. All right, so we can get to there. Now, at this point, what you're wanting to do is you want special numbers that are in your numerator and special numbers that are in your denominator. How do you find those? By setting all the factors equal to 0. Okay?
so x minus
So you're okay finding those special numbers?
I think so.
Okay, so these special numbers, if I set the top equal to 0, I'd get negative 7 over negative 2, which is a positive 7 halves. So 7 halves, and at the bottom I have a 2 and a negative 1. That would make those go to 0, right? Now the only one that makes it really go to 0 is your numerator. And because we have the equal sign there, the 7 halves will have a bracket around it. The other two will not because they're in the denominator. Are we all good with that?
Okay, can you say that again?
Yeah, so if we plug negative 1 in for x, you notice that your denominator is going to go to 0, right?
Yeah.
And do we all understand you cannot have the value of 0 in your denominator? It doesn't work. Do we understand it? Do you want me to go over that real fast? I can do a quick example.
Anything over 0 is just no solution.
Right, well, look at what happens. If I say 0 over 8, 0 divided by 8, okay? So that's what long division is. The top number goes in your box. What times 8 is 0? 0, all right? And so that works. But if you have 0 in your denominator and you take 8 divided by 0, nothing times 0 is going to give you 8. It doesn't work. That's why it's no solution. So you cannot have the whole value of 0 in your denominator. Okay? So these two are in your denominator. They'll give you zeros. So those will be parentheses or open circles on your graph.
So if it gives you 0, it's parentheses, and if it doesn't, it's
No,
like the cube.
in the denominator. In the numerator, that's a good thing. Okay? So now we draw this. Smallest number is -1. Then we go to 2. And then 7/2 is 3.5. So that's bigger. Okay. And now you plug everything in separate form. So -2x plus 7. All right. And then you have x minus 2 and x plus 1. Let me move all this up. Okay. And then your total.
Okay, so what confused me was there would be like, you put these super dark lines and then underneath it you would have like some other thing.
Okay, so I was saying that, and it's not necessary, but to understand where your fraction bar is in the problem. So -2x plus 7 was in your numerator, and the x minus 2 and x plus 1 was in your denominator. You don't need to do it that way, but I was trying to help you try to see it in your brain that eventually you won't need to know that.
Okay.
But to get started, for you to help you better understand it, we can separate it. Okay, that's the only reason I put those there. Okay, so let's just do that. So now are we good with what to do from here?
Yeah.
Okay, so
The writing is the very end, like the whole union thing.
okay, I'm gonna rip through this quickly since we're all good with this. Less than -1 is -1 billion times the negative is positive, so that's gonna be positive. -1 billion minus 2 is negative, and -1 billion plus 1 is still negative. So you have a positive in your numerator. In your denominator, you have negative times a negative, which is positive. So positive divided by positive is positive. Notice that's the same thing as if you just multiply all that together. Positive times a negative is negative, times another negative is positive. So it doesn't really matter that one's in the top and one's in the bottom. Okay, stop doing that. Next, between -1 and 2 is 0. 0 plus 7 is positive. 0 minus 2 is negative. 0 plus 1 is positive. That'll give me a negative. Okay? Between 2 and 3.5, we have 3. So 3 times -2 is -6 plus 7 is positive. 3 minus 2 is positive. 3 plus 1 is positive. That's positive. And bigger than 7/2 is 1 trillion. Times the negative is going to be a big negative. 1 trillion minus 2 is still positive. 1 trillion plus 1 is positive. Multiply those together, you get negative. All right, what are we looking for? We're looking for positive.
Oh, why are we looking for positive?
So, because it says greater than or equal to.
So it's greater than positive.
Yep,
less
so this positive is all those numbers. And the positive is between 2 and 7/2. And then if you remember, I said only color in what makes your numerator 0, which was 7/2, right? And everything else was an open circle, which means those are parentheses. All right, so from here, you go from -infinity to -1. That represents that shaded area. And then you go from 2 to positive 7/2. Do we understand the brackets and the parentheses?
Yeah.
I'm still confused on how do we make sure it's not, so if it's 0 is closed, and if it's not, it's open for the dots, right?
If your numerator goes to 0, okay, and there's the equal sign in the problem. If there's no equal sign, everything's open and it's parentheses. Okay?
I'll probably, I'll talk to you later about this probably tomorrow.
Okay, so those are your two solutions. So you put a union between them.
Okay. That makes sense.
Anything else? Now's the time, guys, not after tomorrow. So if there's one thing that you are really struggling with, now's the time to ask. All right, let's everybody do this problem. This will be 2.7 again. Try to pick something different than what we did. This is number 12. This is x times 3x minus 1 less than or equal to 4. Everybody, you get 2 minutes to solve that. Okay, hopefully you distributed first. And hopefully you moved the 4 over. And then hopefully you tried to factor it. So if you got this far, you're going to get half a point. Okay, so now it's 3x and x and 4 and 1. We need it to be a negative 1x, so negative 4 plus 3x. So that gives me a negative 1x. So my values are positive 4/3 and negative 1. All right, now what do we do with this? We're looking for negative values. Guys, you do not have to make the chart. I alluded to this yesterday. But if you're struggling, the chart will make sure you don't make any errors as far as where it should be. But I want to know how you're getting your answers. So somehow show me those things.
Do it without the chart, though.
Record. Negative 1 billion times 3 is negative 3 billion. Oh, can't see it. All right, so let's move that up. Negative 1 billion times 3 is negative 3 billion minus 4 is a bigger negative. Would you agree? And negative billion plus 1 is still negative. Multiply them together, you get a positive. We are looking for negative values. So we don't want those. Between negative 1 and 4/3 is 0. 3 times 0 is 0 minus 4 is negative. 0 plus 1 is positive. Negative times a positive is negative. So from negative 1 to 4/3, we want that interval. Okay, so we're shading between there. Now the question is, are they brackets or are they parentheses? And you should say that they're brackets because the 3x minus 4 and the x plus 1 are in your numerator. They're all over 1. So if you have zeros in your numerator and you have that equal sign, that means you're including them. Okay, so those, if you're graphing, be shaded in. So those are brackets. Just to make sure there's nothing else, plug 1 billion in. That makes a positive there and a positive there, and the whole thing's positive.
Okay.
You have to sit and think about it, even and pause the video and try to make sense of whatever I just said. You'll get it, but it is going to take you some time to get that stuff. Not everything's going to be difficult, guys. 2.6. Let's do something simple to start with. Express this in interval notation, please. X minus 6 is greater than 5x plus 3. This is number 26 in the book. 30 seconds. So, depending on which way you went, it's easier if your x's are on the left, but you don't have to move them to the left. And I moved the 6 at the same time to the right. So negative 4x is greater than 9. Divide off a negative 4, which changes the direction of your inequality. So x is less than negative 9/4. Just for right now, who got that far? Okay, that's great. Half a point. So less than negative 9/4, which means negative 9/4 is the bigger number. There's no equal sign, so it's parentheses all the way negative infinity to negative 9/4. Who got it right? Okay, some of you didn't get quite enough time, so that's that answer. Let's move on. Solve this problem. 64. Absolute value of 4x plus 7 is less than or equal to 0. Give you another minute. Okay, you should have done right off the bat this right here. Oops, 0.
Oh, yeah.
Okay?
That's what I'm
I'm just curious Is the absolute value less than 0? No.
Isn't it the 7 with the total goal?
So just to go through the motions, because I'm not going to give you a tricky problem like this on the test, we'll just go through the motions of solving it. 4x is greater than or equal to negative 7. Divide off the 4, and you get x is less than or equal to negative 7/4, and x is greater than or equal to negative 7/4. So less than or equal to negative 7/4. So all the values less than or equal to negative 7/4. That would be negative infinity to negative 7/4. Bracket around this negative 7/4. Union with negative 7/4 to positive infinity. And a bracket around that. So think about this for a second.
So
None of the problems are going to make this less than 0. What problem is going to make it equal to 0? What answer is going to make it equal to 0? Negative 7/4 is going to make it equal to 0. All right? So negative 7/4, technically negative 7/4 is going to be the answer to this problem. I'm not going to give you a trick question like this, okay? So this is the process that you'll do to solve that problem. Does everybody understand? Okay, all right.
what was the
4 times negative 7/4 plus 7. That's negative 7 plus 7, which is 0. Absolute value is 0, is less than or equal to 0. So the value that I can plug in for x is going to be equal to 0. Going to make the expression equal to 0. So that's why it has a bracket, because it works.
like that? There's a parentheses or bracket on that side, basically.
Well, there's the bracket. Oh, I see what you're saying. A bracket because it makes it equal to 0. But if there's no equal sign, you got to have that equal sign. If there's no equal sign, it's all parentheses.
Okay, but what about the?
Okay.
It's not funny enough, but
2.5.
why are you laughing?
Because this is why you do your homework intentionally and come into SRT if there's questions and work hard and look up other things and
I am.
if you're struggling. Okay? All right, fine. Here, do this problem. Number 4. 2 times 5x plus 2 minus 1 equals 5. 30 seconds, go. One fifth and negative 1.
What? Oh, I miswrote it.
Okay.
I guess.
It's 35, x to the 4th minus 34x squared plus 225 equals 0. Okay, so as long as the middle term exponent is half of the leading exponent, then you treat it like a normal trinomial, okay? So we're going to split it into 2 binomials. And the exponents that you put there are the middle exponent squared. All right? As long as this is a 1, you just need factors of 225 that add up to negative 34. So, what is it? Negative what?
Negative 25 and negative 9.
Negative 24, negative 25, and negative 9. Difference of squares now. So you have x minus 5, x plus 5, x minus 3, x plus 3. And your answer should be 5, negative 5, 3, and negative 3. All right. Let's do x plus the square root of 5x plus 19 equals -1.
Huh?
You gotta square it.
Ah, negative x forgot.
So your answer should be 6 and -3.
2.4?
2.4. -5 plus 4i. I'm going to change this a little bit. Minus 3 plus 9i. Go. So don't forget to distribute the minus sign through here. So we get -5 plus 4i, minus 3, and a minus 9i. Then put everything together, real numbers. We're looking for a plus bi, that form. So -5 and -3 is -8. And 4 minus 9i is minus 5i. Who got that right?
Is
All
it
right.
pencil or-
I went farther though, I kept simplifying it, I didn't know that's where you're supposed to stop.
Well, you can't simplify that any further
Yeah,
because the 8 doesn't have an i.
yeah.
Okay, everybody. What is I to the 50th power? I to the 4th is 1. So how many I to the 4ths go into I to the 50th? So 12 of them. That makes 48, right? And you have I squared. So that'll give you I to the 50th. So I to the 4th is 1. 1 to the 12th is 1. So 1 times I squared is -1, right? Okay.
I'm just confused on this. Wait, what's -5 come back?
I cubed is the same thing as I squared times I, isn't it?
Yes.
And I squared is -1. So that's -I.